And let's do this thing. Okay, so today our focus is going to be hammering out multiplying binomials. Okay. And so it's important for us to understand what we're meaning here. Multiplication, I hope we understand at this point, but we have to kind of go back a little bit and understand what a binomial is. Okay, a binomial is a two-term expression. So for example, when I'm talking about a two-term expression, I'm talking about things like, I'd have like 3x plus 7. That is two terms. The first term is an x term. The second term I call a constant term. And I call it constant because it's constant. There's no variable. Okay? So that's an example of a binomial expression. Another example of a binomial expression might be 2x squared minus 3x. Again, this is two terms. We have two terms here. We have our x term from before, right? X term. Which in this case is negative 3x. Okay, always view that minus sign as a negative 3. And then we also have an x squared term. Okay. I might even have two different variables involved. I might have a term that's 4x plus 17y. And in this case, again, I have two terms. I have my x term, and I have my y term. Absolutely. I'm running out of colors now. Y term. Okay. So all binomials are going to be built like this. We're going to have a this plus a that. Okay? 3x term plus constant term, squared term plus x term plus y term. These are our binomial expressions. Okay? So one thing that we have to keep in mind is that we cannot combine these terms because they are not like terms. 3x plus 7 is simplified. 2x squared minus 3x is simplified. 4x plus 17y is simplified. Those do not get any more simple because we cannot add those together. Gracie?
Does it have to be two things that can't be added together?
Yes, because otherwise we would just simplify them, right? Because while we could say 2x plus 4x, that's two terms. Well, actually we can just simplify that to 6x, and it's actually a monomial. It's one term. Okay? It's a single term. Okay. So do we understand what we're talking about when we're talking about binomials? Thumbs up, thumbs down. Okay, we get what we're talking about when we're talking about binomials. So when we're talking about multiplying binomials, okay, well, what we're talking about is binomial multiplied by binomial. Okay, because we could do a monomial times a binomial. And actually, let me do that one first because it's pretty simple. I can have a monomial times a binomial. And that might look something like this. That might look like 3 times 2x minus 4. Okay? Here's my monomial right there. And then here is my binomial. Okay? And when I do a monomial times a binomial, what that's telling me to do is that's telling me to distribute. Okay? So I'm going to distribute this 3 into each term. I'm going to distribute into, bless you, each term. So what I end up here is I end up with 3 times 2x, 3 times 2x, and then 3 times a negative 4. Okay? So I would say plus 3 times a negative 4, like that. So this becomes 3 times 2x is 6x, 3 times a negative 4 is is negative 12. So I would have 6x minus 12. This would be my answer, right? That's a monomial times a binomial. Any questions on this? Feeling good? Feeling mellow? Beautiful. Okay, so now where things get complicated, and I'm going to zoom in for this, make sure it's nice and big. Where things get complicated is when we start doing binomials times another binomial. Okay. So in this case, it might be something like, I'll keep my 2x minus 4. But this time I might multiply it by something else. Maybe in this case it'll be x plus 3. Okay? So now I'm doing a binomial times a binomial. And so what does this mean? Okay? Well, when we look up here, we see that I took this and I multiplied it by each thing. That's essentially true. That's essentially true here. So now instead of 3, I have x plus 3. But I can distribute this. This can be times this, and this can be times this. So what I end up with is I end up with x plus 3 times 2x. And then I'm going to add that to a x plus 3 times a negative 4. Okay? Yeah? We'll get there. We'll get there. I just want to explain why this works first. Okay? And see, this is exactly the same as when I was doing a monomial. Before, I had this 3 that I distributed in. Now I'm doing the exact same 3. I would end up with a 3 here and a 3 here, times 2x times a negative 4. This is the exact same thing, except this time I'm treating it as an x plus 3. So I have an x plus 3 times 2x and an x plus 3 times a negative 4. So when we do this, we simplify it out. 2x times x becomes 2x squared. 2x times 3 becomes 6x. Negative 4 times x is a minus 4x. And then negative 4 times 3 is a negative 12. Now I just need to simplify, combine my like terms. I have 2x terms. So this becomes simply enough 2x squared plus 2x minus 12. And that is our answer. Okay? This is a complicated way of doing it. So we've developed a couple of shortcuts to help us with this. Okay, instead of taking all of this and multiplying it here and there, we've developed a way to make this a little bit easier. And so what we're going to do is we're going to do the exact same binomial multiplication, but I'm going to show you 2 different ways of getting the same answer so that you can use the way that works best for you. Okay. So once again, I'm going to rewrite those binomials that we just used. We had x plus 3, and we were multiplying that by 2x minus 4. The most common method, the method that was taught to me when I was in high school so long ago, before any of you were born, it's known as the FOIL method. FOIL, of course, stands for first, outer, inner, and last. So what we do is we look at our 2 expressions and we find the numbers that are first. In this case, the first terms are the x and the 2x. So I'm going to start by multiplying those together. I have x times 2x, which of course simplifies to simply 2x squared. Next, I do the outer numbers. These are the numbers on the outside, so I have an x and a negative 4. So I'm going to add an x times a negative 4, which becomes negative 4x. Next are the inner numbers, the numbers on the inside, 3 and 2x. So plus 3 times 2x. Whoops, I should have written that here. Plus 3 times 2x, because that becomes 6x. And finally, my last numbers, which are 3 and negative 4. So plus 3 times negative 4, or negative 12. Thus, I have this expression here. I combine my like terms, 2x squared plus 2x minus 12. Exact same response as we got before. Okay. We do not add these together because they are not like terms. X squared is not the same as an x. X is not the same as a constant. X squared is not the same as a constant. This is our simplified form. Finally, an additional method is known as the box method. It's my binomial in a box. So what we do, have you guys ever done Punnett squares in science and biology? It's very similar, okay? So what I'm going to do is I'm going to create a quick little box that resembles a Punnett square. Okay. So I'm going to start with my first term, which is x plus 3. I'm going to put this here. And then I'm going to look at my other term, which is 2x minus 4. I'm going to put this here. I'm then going to fill in my boxes with each of my terms. So this will be x, and this will be 3. I got my x from here and my 3 from here. Guys, you want to be writing this down. Next, I'm going to do the same thing here. I'm going to have 2x and minus 4. Okay? Does everyone get where I got these numbers from? Where I got x plus 3 from? Gracie? No, it doesn't matter. It doesn't matter if I chose this one to be on top and this one to be on the side or vice versa. It doesn't matter if I put 3 here or x here. None of it matters as long as this first term over here ends up together and this second binomial here ends up together. That's the only thing that matters, is that those ones end up together. Okay? So now all I do is I fill this in like a times table. I just multiply each thing by each other. So I have x times 2x, so that becomes 2x squared. All right? I have x times negative 4, becomes negative 4x. I have 2x times 3, which becomes 6x. And then I have negative 4 times 3, which becomes minus 12. Okay? So now I have it all lined up in a box. So all I have to do is turn it into a single expression. So I'll have 2x squared, bink, plus 6x, boop, minus 4x, shablow, minus 12, kazam. Combine my like terms, 2x squared plus 2x minus 12. And sure enough, you can see that each of these methods got us the exact same result. Okay? So my whole point in doing this is giving you guys multiple ways of solving these problems, multiple ways of being able to do these binomials. Okay? Does anybody have any questions on this? Are we feeling good, feeling mellow? This was the number one problem that I saw us get wrong on this quiz, and it is an absolutely necessary skill to move on to the next level. Alrighty. So with that said, I'm going to stop this video and give you the homework.